I'd like to start off by acknowledging my biases. I've been engaged in computer-based systems modeling for almost all my life. Bear that in mind as we go forward. I would also like to acknowledge that I'm going to frame the argument that I make based on a book by William Byers called Deep Thinking. And it seems to me deep thinking is what is required to confront the challenges that have been so well identified thus far in our discussion. To summarize the challenge, I wrote down managing in the Anthropocene. We have come to realize that not only do we affect natural systems, we are indeed responsible for them. Most of the problems, global challenges that we face are subsumed in that, and I won't try and elaborate because it's been well elaborated. But where Byers goes is, given a problem domain, he likes to think of the conceptual system that we use to think about the problem domain. And furthermore, he suggests that deep thinking emerges when we can hold two conceptual systems in our hands, and we can see that the conceptual systems are incoherent in certain instances with one another. That causes us to think about a broader, grander conceptual system that encompasses the positive elements of these conflicting, more primary conceptual systems. I'm going to propose that the two conceptual systems that we have in our hands, but not in all our hands, because most of us live in one or the other, but can't see the other at all. The first conceptual system I'm going to label as Newtonian. Newtonian systems can be recognized as being reductionist. They can be characterized as being mechanical, reversible. It's a conceptual system that is governed by timeless and universal laws. It's deterministic. There is no room in that conceptual system for very much choice. It is determined. Once you know the laws of motion of the system, you can predict the future of the system just as you can predict the past, provided you can observe one point at one time in the system. The observer then, we people, are outside of the system. We're not part of the worldview, or the second conceptual system is what I call evolutionary. It's not reductionist. The whole is greater than the sum of the parts. Time is fundamental and is not reversible. There's no reversibility. This is a system in which the second law of thermodynamics is fully represented, if you like. These systems, the Earth system, then, is a system of processes that are far from thermodynamic equilibrium. And so, unlike the Newtonian systems that like to focus on equilibrium and comparative statics, comparing equilibrium points, evolutionary systems are systems in which dynamics are essential. In systems that are far from thermodynamic equilibrium, as energy passes through from low entropy energy from the sun to high entropy energy that is radiated back in space, there can be and there is the generation of order. So evolutionary systems create order, create more and more distinctions, if you like, and distinctions become important. To understand these systems, you have to understand the degrees of order and complexity, as they emerge over time. So there's not an emphasis on reducing to a small set of fundamental laws. You have to confront complexity head on because that's the nature of these evolutionary systems. Humans are an integral part of the system. And in fact, I guess what we see is that now the accumulation of knowledge and know-how in humans, in fact, is the way in which evolutionary pressures are being expressed. That's responsible for the generation of order. What this implies is that there is no predictability in these systems. We cannot predict what we are going to learn, as Boulding says, or we would know it already. So that you have to abandon in this worldview the notion of a predictable future. Another aspect of evolutionary systems are that the laws and rules of the system by which are emergent. So there are no fundamental laws. The laws are context and rules are context dependent, and as the context evolves in more complex form, then rule systems and laws evolve and change. So there are no fundamental universal laws. This difference between these two conceptual systems has been confronted in physical sciences. Physics has remained very much in the Newtonian worldview, but there are a couple of exceptions. At the very micro scale, at the particle scale, then we have the notion that the observer fundamentally changed the system that he's being observed. So there's a bit of a breaking there, an encompassing of the evolutionary worldview at the small scale. At the large scale, in cosmology, there's also the notion that the universe is finite, and that the laws of the system come from within. And there's some work in physics that is acknowledging the confrontation between the physics of the small scale and cosmology. One has to introduce notions of evolutionary systems. In the social sciences, and by social sciences I really mean economics, I suppose, as economics is maybe to assert this, is the king of the social sciences. It's the one from which policy is generated. Economics is pretty firmly in the Newtonian worldview. They attempted, well, more than attempted, economics, mainstream economic theory, borrowed from the evolutionary world, which was focused on the survival of the fittest. It borrowed the idea of competition, but it made competition one of the axioms of economics, not something to be observed or measured, but one of the axioms. But that's as far as economics went in acknowledging the evolutionary worldview. Mind you, from as early as 1899, Thorsten Veblen was arguing that economics should be an evolutionary science. Certainly Kenneth Boulding, now in the 60s and 1960s and 1970s, who became president of the American Economics Association, argued very strongly for an evolutionary worldview. He was firmly rejected by the mainstream of economics. And Kenneth Bowling has almost disappeared from view, regrettably. Well, let's take these two conceptual systems then and examine a little bit how these systems apply to the problem domain that we're commonly interested in here. They're certainly incoherent. It seems to me when we do that, there are a number of implications. The first has to do with the scope of economics. It seems to me that economics has to become much more universal. It has to encompass both physical and social systems. That no longer can we tear these two things apart, but they have to be brought together. And it seems to me that by and large we need to frame these issues in economics as being global in geographic scope. Because of the acceptance now of planetary limits. We can only deal with planetary limits if we treat the system from a global perspective. So that's a shift essentially in economics from a national to a global perspective. If we take prediction off the table as being something useful, then I would see that the new economics, this new broadly scoped economics, has to deal with the creation of the tools that enable us or help us to see the long-term and systemic consequences of what we human beings do. By and large, human beings are from an evolutionary sense, are not well equipped to do that. We're very well equipped in our senses and in our capacity for abstraction and communication to survive very well in the here and now, and in fact to become a dominant species in the here and now. But by and large, we're not well equipped to take into account the long-term and systemic consequences of what we do, and because of that, we're in the mess that we now perceive ourselves to be in. And so what we are looking for economics to deliver, this new economics to delivery, is a set of tools, then not a representation of a whole system, but tools to be used in conjunction to expand our capacities to perceive. Just like a telescope is a device that helps us perceive things that our eyes wouldn't enable us to see. We need a device, and the device has already been named. The device is called a macroscope, and it was coined by Joel Dorosny some time ago, although as far as I know it has never been manifest, it's not an idea that's been implemented. The new economics is then, I think, has to deal with two fundamental concepts. It has to deal with concepts in the biophysical world, and the primary concept in the biophysical world is the concept of process. So the concept of a process within a boundary that takes things coming into it, transform it, and something else comes out, and dynamic as well. So different time scales for things coming in and things coming out. And those are the concepts that we have to use to frame the biophysical part of the world in which we're interested. But we're also interested in the social dimension, and the social dimension is something that Kenneth Boulding called the noosphere. It's the mind space of humanity, if you want to call it that. The mind space of humanity consists of agents, and agents mostly deal in information. These agents change, if you like, influence the biophysical world. So we build things, we build processes, and so on, that are purposeful, that suit our purposes. And so we have a biophysical world that consists of two kinds of processes naturally occurring and human created. And then we have a mind space that's populated by agents. And agents can be thought of are complex. Agents are individuals, agents are collections of individuals, agents are individuals that are bound into institutions. Agents' behavior is determined by rule sets. What I'll say is that agents engage in exchange. And when they engage in exchange, they basically keep books. We keep balance sheets and we keep income statements. And there's a coherence to exchange that's imposed by keeping these books, which we've been doing now for hundreds, if not thousands of years. And so I'm going to suggest that when we deal with this space of institutions, that our primary interest is in representing the constraints that are imposed by exchange systems. And so we've got two sets of constraints on where this whole system can go. One are biophysical, the boundaries, if you like, and the other set of constraints are constraints that deal with exchange. Within those bounds, then, what we need is exploratory analysis to see where this system can go. And when we can see the possibilities, that cone of possibilities, then it's a political choice to determine what is the pathway that best suits. One more point, I guess. One of the areas where there has been a successful approach to understanding complex systems, of which this is what we're talking about, complex adaptive systems. The analogy I like to draw is climate modeling. There is no macroeconomic theory of the climate. Climate models are detailed process models with a great deal of location-specific and process-specific and dynamic transformations. The only way that we here can begin to comprehend complex systems is in fact to build models of them that bring together all these bits and pieces in ways that our brains could never do. I will only argue that the climate models we have were confined essentially to natural systems. They did not couple well to the current set of economic models, and so we've missed a great deal because the economic models were Newtonian and all kinds of things were wrong with them. And so I end up advocating that the way economics in a way is going to have to move forward will be a bit of an analog to the way climate science has moved forward in response to the perceived problem. And that means a synthesis of a great deal of understanding of the constituent processes, both biophysical and both institutional.